Hello, Physics Life YouTube channel. Today we are discussing about the GM counter. So, GM counter is an instrument for detecting and measuring ionizing radiations, alpha, beta, gamma radiations. Okay, so what is GM counter? It is an instrument for detecting and measuring the ionizing radiations, alpha, beta, gamma radiations. Okay, once again you want to repeat these things. GM counter is an instrument for detecting and measuring ionizing radiations, alpha, beta, gamma radiations. Okay, the charged particle ionize the gas through which they pass. When the charged particle ionize the gas through which they pass, the electrons so produced during ionization get accelerated under high potential further produce ionization. So this is the basic point behind GM counter. The working principle: when a charged particle ionize the gas through which they pass. Okay, so some radiations or alpha, beta, gamma radiations comes to this that ionize the gas through which they pass. The electrons are produced during ionization and that electrons get accelerated under high potential, so it produces further ionization. The main advantages are that they are relatively inexpensive, durable and easily portable. The main advantages of GM counter is inexpensive, durable and easily portable. So what is the main advantages of GM counter? Inexpensive, durable and portable. And what is the working principle of GM counter? When a charged particle ionize the gas through which they pass, the electrons so produced during ionization get accelerated under high potential further produce ionization. Okay, so when a charged particle pass through the gas, it ionizes the gas and it produce electrons, so that electrons get accelerated under high potential and further produce ionization. Okay, so what is the disadvantage of GM counter? That is low efficiency. Low efficiency is the disadvantage of GM counter. Low efficiency. So what is the advantages of GM counter? That is inexpensive, durable and easily portable. And what is the working principle of GM counter? GM counter is when a charged particle ionize the gas through which that pass, the electrons get produced and during ionization and get accelerated under high potential and further produce ionizations. Okay, and what is GM counter? GM counter is an instrument for detecting and measuring ionizing radiations, alpha, beta, gamma radiation. It is an instrument for detecting and measuring ionizing radiations, alpha, beta, gamma radiations. Okay, and what is the construction inside that? Construction of GM counter. A GM counter in which a GM tube is there. What is GM tube? GM tube is a charged capacitor with a region between them occupied by a gas. Okay, so what is GM tube? GM tube or Geiger tube. Geiger tube or GM tube is a charged capacitor. What is that? Charged capacitor with a region between them occupied by a gas. A capacitor, we know that there is electrodes, and that is there is a region between them that is occupied by a gas. Okay, and what is the construction? First point, that is, it is a Giger tube is there. It is a charged capacitor with a region between them occupied by a gas. And next, the apparatus is totally, we can say that it is a tube plus counter and power supply. So GM counter, it is an apparatus which consists of tube and counter and power supply. Tube and counter and power supply. Okay, so tube plus counter and power supply is the apparatus of GM counter. So GM tube, usually a cylindrical tube. GM tube is usually a cylindrical one with a wire down the center. So it is a cylindrical only GM tube and with a wire down the center. So the counter and power supply have voltage controls and timer options. Counter and power supply have voltage controls and time options. Okay. So the apparatus consists of tube and counter and power supply. The GM tube is usually a cylindrical tube with a wire down the center. The counter and power supply have high voltage controls and timer options are there. A high voltage across the cylindrical tube, across the cylinder and the wire. There is a high voltage across the cylinder and the wire. We know that the GM tube is the cylindrical one, that is a charged capacitor. We know that is a cylinder with a wire down the center, and we know that it is there is a high voltage across the wire and the cylinder. The anode are usually thin metal wires. Anodes are usually thin metal wires which are held at a positive potential with respect to the rest of the detector. We know that there is a electrode, there is anode and cathode is the for that. Anode is usually a thin metal wire. Okay, thin metal wires which are held at a positive. We know that anodes are positive, and that is thin metal wires. We know that there is a cylindrical shape tube, and inside that there is a wire down the center. That thin metal wires are anodes, and that held at a positive potential with respect to the rest of the detector. Okay, you understood? And the cathode is cylinder. So the GM tube in which cylinder is cathode, wire is anode. Anode is at positive potential, cathode is at negative, and it is arranged in a coaxial manner. We know that there is a cylinder shape is there, and cylinder shape, and inside that there is a wire down at the center. The metal wire at the center, surrounding there was a cylinder, that is cathode. Okay, the cathode is cylinder arranged in a coaxial manner this metal wire at the center surrounding that the cathode cylinder. So that is cathode. The metal wire is anode. Okay, you understood? The voltage source will create electric field between the electrodes. So we know that there was a voltage source is there and which create electric field between electrodes. So electrodes, cathode and anode is there, and an electrometer circuit that is capable of measuring small output current. Okay, so the voltage source will create an electric field between the electrodes and electrometer circuit which is capable of measuring very small output current. Okay, so this was the construction behind GM counter. So all these things are there. A GM tube is a charged capacitor with a region between them occupied by a gas, and the apparatus it consists of tube and counter and power supply. The GM tube is a cylindrical one with a wire down at the center. Sorry, this is a cylindrical shape and wire at the center. And the counter and power supply have voltage controls and timer options. A high voltage across the cylinder and the wire. The anode are usually thin metal wires and which are held at a positive potential with respect to the rest of the detector. The cathode is a cylindrical cylinder. It is arranged in a coaxial manner. This metal wire is at the center surrounding that the cathode cylinder. Okay, so metal wire is anode, cylinder it is cathode. The voltage source will create an electric field between the electrodes and electrometer circuit is there for capable of measuring very small output current. And what was the working principle? When an ionizing radiation such as alpha, beta, gamma particle enters the tube, it can ionize some of the gas molecules in the tube. Okay, so when an ionizing radiation such as alpha, beta or gamma particle enters the tube, it can ionize some of the gases or molecules in the tube. From these ionized atoms, an electron is knocked out of the atom. From these ionized atoms. So first of all, the particles enters the tube, it ionizes the gas and ionize the gas or molecules in the tubes, and that ionized atoms from which an electron is knocked out of the atom and the remaining atom is positively charged. The high voltage to the tube produce electric field inside the tube, and the high voltage to the tube produce an electric field, and there is electrons attracted to the anode because anode it is at a positive potential and the electron should be attracted to the anode. Positively charged ions attracted towards the cathode. The electrons are attracted towards the anode. Positively charged ions attracted towards the cathode. Okay, so this produces a pulse of current. The pulse is counted. So that is GM counter. The charged ions become neutralized. The GM counter ready to record another pulse to restore GM count with a quickly to its original state after radiation has entered. A gas is added to the tube. Okay, the gas is called quench gas. To ensure each pulse discharge terminates a common mixture 90% argon plus 10% methane. Okay, so all these things we know. So first of all, the working principle. For that, when an ionizing radiation such as alpha, beta, gamma enters the tube, it can ionize some of the gas molecules in the tube. From these ionized atoms or gas molecules, from which an electron is knocked out of the atom and the remaining atom is positively charged. That we know. The high voltage to the tube produces an electric field inside the tube, and we know that electrons should be attracted to the anode, that is positive electrode, and positively charged ions attracted towards the cathode. This produces a pulse of current and the pulse is counted. Okay, the pulse is counted. The charged ions become neutralized. After this, the charged ions become neutralized. The GM counter is ready to record another pulse. So it is ready to record another pulse. To restore GM counter with a quickly to its original state after radiation has entered, a gas is added to the tube. So to ensure to restore the GM counter to its original state, a gas is called quench gas is filled into that tube to restore the GM counter quickly to count another pulse. For that, some gas is added. That gas is called quench gas. So, to restore GM counter too quickly to its original state after radiation has entered, a gas is added to the tube. The gas is called quench gas. To ensure each pulse discharge terminates, a common mixture is used for that. To ensure each pulse discharge terminates, okay, that mixture of gas is called 90% of argon is the common one plus 10% of methane. That is for to ensure to restore GM counter tube quickly to its original state. Okay, to restore it into an original state, we should add some quench gas into that of GM tube. For low voltage, no counts are recorded. For low voltages, no counts are recorded. This is because the electric field is too weak for even one pulse is to be recorded. So the electric field is too weak for that. For a low voltage should not create any count. So for low voltage, no counts are recorded. This is because the electric field is too weak for even one pulse to be recorded. As the voltage is increased, eventually one obtains a counting rate. As the voltage is increased, eventually one obtains a counting rate. We know that we get after increasing the voltage, we should get a pulse. Eventually gets an counting rate we can get from that by increasing voltage. The voltage at which the GM tube just begins to count is called starting potential. Okay, the voltage at which the GM tube just begins to count is called starting potential. The voltage at which the GM tube just begins to count is called the starting potential. The counting rate quickly increases when the voltage is increased. The counting rate quickly increases when the voltage is increased. We know that for a low voltage there is no count are recorded. This is because electric field is too weak for even one pulse is to be recorded. As the voltage is increased, As the voltage is increased, eventually one obtains a counting rate. The voltage at which GM tube just begins to count is called the starting potential. The count rate quickly increases when the voltage is increased. The rise is so fast. The graph look like a step potential. The rise is too fast. It look like a step potential. After the quick rise, the counting rate is level off. The range of voltage is termed as plateau region. So what is meant by plateau region? After a quick rise, we know that we get a quick rise, there should be some level off. The range of voltages is called plateau region. Okay, there is a quick rise with a count and voltage. There was a quick rise and then there was a level off. This is called plateau region. Eventually the voltage becomes too high, we have a continuous discharge. So we get a continuous discharge. When the voltage increases, there should be we get a continuous discharge. What is threshold voltage? Threshold voltage where the plateau region begins. The threshold voltage, the voltage where the plateau region begins. The proper operation when the voltage is in the plateau region in the curve. So the voltage for the GM counter should be in the proper operation. For that, we should select a voltage in the plateau region. So the proper operation for that, the voltage is in the plateau region. And important that is next is dead time. So what is dead time? Dead time after at each count is recorded, it takes GM counter for a certain amount of time to reset itself, to be ready to record the next count. The resolving time is called dead time. Okay, so the dead time after a count has been recorded, it takes GM cube a certain amount of time to reset itself to ready to record the next count. The resolving time is called resolving time or dead time. The dead time or resolving time after a count has been recorded, it takes GM tube a certain amount of time to reset itself to be ready to record the next count. The resolving time or dead time, it is called the resolving time or dead time. After each count, the tube needs a certain amount of time to reset. That time is called resolving time or dead time. This is the graph of GM tube, GM counter. For that, there was a rise in the counts with the voltage, and there was a threshold voltage. After that the curve like a level of that should be a plateau region. After that, this is a breakdown voltage. After that, discharge region. When voltage very big, then that discharge, there is a continuous discharge happens. Okay, so that is called discharge region. So once again, for this working principle, for that we should revise the things. We should revise the things from here. We know that there should be a quench gas to restore the GM counter tube to its original state. The quench gas is 90% of argon plus 10% of methane is commonly. To restore the GM tube into its original state, we should add some gases, that is quench gas. For low voltage, there is no count, we know that, because there is electric field is too weak for one pulse to be recorded. When the voltage is increased, we get a counting rate. Okay. The voltage at which GM tube just begin to count is called a starting potential. The count just starts, that is a starting potential. The counting rate quickly increases when the voltage is increased, rises so fast, the graph rises too fast, that is look like a step potential. After a quick rise, there was some level of that region is called plateau region. Eventually, the voltage becomes too high, we get a continuous discharge that is look like this graph. And the threshold voltage where the plateau region begins. The proper operation when the voltage is in the plateau region of the curve. Plateau region of the curve. Okay, the voltage is in the plateau region of the curve, that should be a proper operation. What is dead time? Dead time, after a count has been recorded, the GM tube take a certain amount of time to reset itself to be ready to record the next count. That time is called dead time or resolving time. This was the graph. This was threshold voltage. This was breakdown voltage. This is plateau region. This is discharge region. So this is all about GM counter. Thank you and subscribe my channel.